This is a quick start video showing you how Sirio works, what it does, but it's not giving a detailed explanation of all the different parameters that are in the software. And for this, I would refer to the manual or the other instruction videos that are included in Sirio. So Sirio is a tool to design rainwater systems, and it uses long-term simulations to do so. So in fact, we will simulate 100 years of rainfall data minute by minute and then analyze how the system behaves to this data. So Sirio works in three different functions, or in three steps. In the first step, we have to include the design parameters and build a simplified model using reservoirs. In the next slide, I'll show you how this works precisely. Then once we've built our model, we can run a 100-year simulation, also including climate change if we want. And then finally, in the third step, we'll do some statistical post-processing in the software, which translates our simulation results in direct design criteria. Now, the last two steps are done fully automatically in Sirio, so we only have to focus on getting the right parameters. So I'll show you how this works in Sirio. So here we can see a reservoir. This is in fact a building stone of the model in Sirio. So a Sirio model will consist of one or more of these reservoirs, and each such reservoir represents part of our rainwater system. Of course, the shape is arbitrary. It can have any shape. Here it's just a very simple rectangular cross-section. But here on the figure you can also see all the different streams that can be included in a model. So we have of course rainfall, but we can also reuse water, account for evaporation, we can connect different houses, different sources. We can also connect different reservoirs to each other, so we can also have an inflow from other reservoirs. Then we have a true flow, one or more of these true flows actually. So these can represent orifices or pumps or anything else. We also have an overflow, so when the capacity of the reservoir is reached, water can be spilled via the overflow. We have infiltration and also drainage that can be accounted for. So now I'll show you how this works in Sirio. This is the opening screen in Sirio. We have 5 tabs and I will go through them. So the first one is the general tab. Here we can load projects, we can supply some comments, we can change our simulation parameters here, we can also provide optional or default model parameters, and here we have some examples that elaborate models. Now let me go to the second tab, the model tab. Here we can see a model that is being loaded. So this, in fact, these different rectangles, they represent reservoirs. So each rectangle is a different reservoir. And we can have more or fewer depending on how big your system is. Then if we click here on select reservoir, we see that our mouse changes from pointer to a crosshair, and then we can select one of these reservoirs. After we've selected a reservoir, the parameters will show up here on your right hand side. So here we have some general parameters. Of course, looking at rainfall runoff areas, runoff coefficients, and so on. So again, I'm not going into detail on all these different parameters. For this, I refer to the manual of Sirio. Here we have an overflow. We also can make connections, so true flows, like pumps or orifices. We can specify the dimensions of a reservoir. There are multiple options here underneath this button. We have infiltration and drainage possible. We can also account for groundwater, for instance. We can have water reuse, evaporation, and also additional incoming flows from another source. So these are all the different parameters that can be included in a Sirio model. Now, in fact, there is also a second module available in Sirio. It's called the parcel module, and this one represents one parcel or one house in, for instance, an allotment or a new design. And these follow the Flemish design rules. So we have a rainwater tank and we also have an infiltration basin. The parcel model can consist of any of these two elements or the combination of both. So in general, for the rainwater tank, it's being filled by the runoff of one roof. We can also have some reuse, and the rainwater tank will spill into the infiltration basin once it's full. The infiltration basin can have a second runoff area, for instance the terrain. There is of course infiltration possible, and there is then again the overflow to the reservoir. Now this parcel module was included to facilitate the modeling of houses or include houses in a project. And let me demonstrate that in Sirio. So here underneath this button, the parcel module is our house. So here you can see the rainwater tank, we can include it or exclude it, and the infiltration basin, each with its own parameters. And again, you can also account for the groundwater level here. Underneath this button are the Flemish design rules. So you're referred to the manual to know more about that. Now the point is that once you have defined different elements here, different reservoirs, you can easily connect multiple of these parcel modules to each of these elements. So as you can see, this element holds 5 different parcels, and this element again holds 5 parcels. But the point is that we only have to supply all these parameters once. So then it's really easy to connect them to these different reservoirs. Now then I can simulate a model. So now 100 years of rainfall data is being simulated. Every 30 seconds is being calculated. And then here we can see the simulation results in this sheet. So on the left hand side we have the mass balance, which shows us how much water is coming in over this 100-year period and how much mass is going out. The maxima and the emptying time are also being stored. You can see this for total, which is in fact the sum of all the elements in the system, or you can look at the parcel modules individually or the different elements individually as well. So for instance, in this case, we see that we have over a period of 100 years, a total runoff from rainfall of 134,800 cubic meters. Since this is the only incoming flow, it's also 100% of the incoming flow. And for the outgoing volumes, we can see that over the entire project, we have about 98,000 cubic meters, of infiltration over a period of 100 years. We have about 36,000 cubic meters of water reuse, and we have an overflow volume of 409 cubic meters over 100 years. So the infiltration is in this case 73% of the total outgoing volume, and 27% is being reused. You can also see this for one parcel module here for the rainwater tank and for the infiltration basin. Now I'll show you some of the more detailed analysis. Here you can select different analyses that are available for different elements. Here we're looking at total. Here we can see the overflow volumes for different return periods. This is a log scale, so that means that this has a return period of 1 year, 2 years, 3 years, and so on. This one is 10 years and this one is 100 years. So here in these results, we can see that we have an overflow of approximately 120 cubic meters once every 100 year. Once every 50 year, for instance, we have an overflow event of about 60 cubic meters. Here you can see the overflow discharge, and here you can see the number of overflow events over a 100-year period, and it's 23. So that means that our design will spill every 4 to 5 years on average. And here again you can see all the different volumes and all the different flows that are being calculated. You can do the same analysis for the true flow. In this case there is no true flow defined, so it's empty. And here you can see the degree of filling, for instance, for the rainwater tank. So here you can see how often the rainwater tank is empty, or how often the infiltration basin is empty or will be filled up to a certain percentage. So here you can see that 80% of the time our infiltration basin is filled for approximately 15% or less. That's how you can interpret this analysis. Of course, you can also look at all the different time series. You can zoom in using these plots, or you can zoom in using this magnifier. And then there are some more advanced simulations. I'm not going over these. Have a look in the manual to know more about it, or try it yourself on a different model. This tab overview gives us an overview of all the different parameters that are included in the model. You can also export them to Excel. Sometimes Sirio will also give you a validation warning before you start simulating an event. And such validation warning indicates that there is a value deviating from expected values, so that there is a bit of strange value. And then one of these cells will be highlighted, and if you click on it, there will be a validation warning here on your right hand side. And then finally, here in the last tab, there is some additional information about Sirio, and here you also have a link to the manual of Sirio.